We're finishing up section 5-9b and operations with complex numbers, and I want you to be able to divide complex numbers or simplify them. And I want to remind you that I equals the square root of -1, and that the complex conjugate of any complex number a plus bi is a minus bi. Now, we went over this in section 5.5, and I told you that we would be using it later to simplify complex numbers, and so we're going to be using it today. To find the complex conjugate, you want to take the opposite of bi and then write bi last, and that's all you need to do. So we're looking at some complex numbers, and we're going to list their conjugates. So the first one is 2 plus 3i. So the complex conjugate for that one, you're just going to take the opposite of bi and then write bi last. Well, bi is already last, so it's just 2 minus 3i. Now, if we look at the next one here, we have -6i minus 8. So we're taking the opposite of I. Now, I mentioned before that a lot of people will tell me that this is -6i plus 8. And that is not the case, because you need to take the opposite of bi. So that would be -6i will go to +6i, and then you're going to subtract 8. This one doesn't change. So then you're going to write the bi portion of the complex number last. So it's going to be -8 plus 6i. Now we're going to move on to another complex number. We have -3i, and the complex conjugate is just going to be 3i. And here we have 8i, so the complex conjugate is just -8i. All right. In section 1.3, an expression that is simplified cannot have a square root in the denominator. And since I represents the square root of -1, it cannot be in the denominator. So that's what we're going to have to simplify. In section 1.3, you simplified 5 over the square root of 10 by multiplying the numerator and the denominator by the square root of 10, because we could not have a square root in the denominator. In this section, you will use the complex conjugate of a number to simplify. So here we are with our first example, and it is 3 plus 8i divided by -i. Okay, so the problem here is that we have -i in the denominator, and I represents the square root of -1. So we're going to have to multiply by its conjugate, and its conjugate is just -i. The conjugate of -i is just I. So we're going to multiply the numerator and denominator. So I just rewrote it over here. Remember, as long as you multiply the numerator and denominator by the same thing, you're not changing the value of the expression at all. So now, from yesterday, we're going to distribute. So we're going to multiply 3 times I, and then 8i times I. So that's going to give you 3i plus 8i squared. And then in the denominator, -i times I is just going to be -i squared. So we're going to go back and change all of these I squareds to -1. And this one gets changed to -1. Remember, there's already a negative out there. So when we go and simplify that, we're going to have 3i, and instead of being plus 8 here, we have the -1, so it's going to be a -8, and then I squared changes to -1, but there's already a negative in front of that, so it's going to be a +1. So the simplified expression is going to be -8 plus 3i. All right, let's do one more. We have the next problem, which is 3 minus I over 2 minus I. And again, we have the square root of -1 in the denominator. Now, if you just multiply by I in the numerator and denominator, it'll get rid of this I, but it'll put the I on the 2. It'll be 2I when you distribute it. So for that reason, you need to multiply by its conjugate. So here we have the expression. We'll multiply by 2 plus I in the numerator and the denominator. And now yesterday you FOILed, so you're going to do the same thing, but you're going to FOIL the numerator and the denominator this time. And when you do that, you should have 4 terms in the numerator, 4 terms in the denominator. So we're going to take 3 times 2, and that's where I got the 6. And 3 times I, so that's the plus 3I. And then negative I times 2 is negative 2I. And then I times I is just going to be, well, this is negative I times I is a negative I squared. All right, then we're going to go to the denominator and do the same thing. 2 times 2 is going to give you 4. And then we have 2 times I is the 2I. Negative I times 2 is the negative 2I. And then negative 1, negative I times I is going to give you a negative I squared. All right, so let's go back and just circle all of these I squareds. They change to negative 1. Here's an I squared. That changes to negative 1. All right, now we can combine like terms. So in the numerator, we can write that as 6 goes down here, and then these 2 terms combined are just going to give me 9, or I, sorry. And then we have a negative 1 here, but it's subtracting a negative 1, so that's going to be a plus 1 in the numerator. And then in the denominator, the plus 2I and minus 2I, just that changes to 0. So we have a 4. And then we have an I squared, which we changed to negative 1, and we already have a negative out in front there, so it's going to be a plus 1. So in the denominator we have 4, and this whole thing changes to plus 1. So when we combine like terms, 6 plus 1 is 7, and then we have plus I, and in the denominator we have 4 plus 1, which is 5. And again, you can split them up and write it as 7 over 5 plus I over 5. Either one of those are fine.